Hello everyone. Today we will be solving Leetcode number 13, Roman to integer. So this will basically, we're converting a Roman numeral to an integer. So pretty classic problem here. As you can see, a lot of people have attended this. What are the most popular questions, again, in coding? To be fair, this is a decently difficult problem compared to some other easy rated problems. I would probably rate this problem a medium, but then again, there are some really hard mediums, so I don't know, maybe Leetcode rated this accurately. But this problem becomes pretty easy if we use a hash map again, so when you're in doubt, always use a hash map like here. The reason why this problem is so annoying is because we have additive cases and subtractive cases. Let me just call this normal cases. So normal cases are basically just like, for example, I, which is 1, V, which is 5. So we just, these are all the normal symbols, right? But there's also very annoying cases where, you have IV, which is 4, IX is 9. So if you don't know what Roman numerals, how they work, it's just additive. For example, the Roman numerals are just all of these symbols and their values, and you add them together. So it's all additive, so that makes it a bit easier. But there's at most like 3 symbols, 3 like of the same symbols put consecutively. So if the number is 3, it's I. But if you have to write 4, you can't write 4 I's. You have to do IV. So you're gonna have to put the I in front of the 5 to show that you're subtracting 1 from 5 to make it 4. So that's really annoying. Basically, the real difficulty of this problem is how we handle these special cases. So we're just going to make a hash map real quick for the normal cases, and for the special cases, which are subtractive cases, we're going to have, I think there's 6 of them. So this is going to be 4, this is going to be 9, okay, so once we do this, what we need to do is we need to check, like each character in the string that we're given, and also check the character after it to make sure it is not a special case. So let me just finish this hash map real quick. Okay, so those are the hash maps that we need. They make it a lot easier here. So now let's see. We're going to use a while loop to loop through every element in the string that we're presented, which is S. So while, let's say I is equal to 0. Also, let's say we have to have an output. Actually, we can set both to 0. So while I is less than the length of S, obviously, because it has to be a valid index while that happens here, we're going to check if I plus 1, if there's a valid index after it, which means, if you're at the last index, there obviously is not going to be another index after it. So, we're going to check if there's a valid index after it, and, if S of I plus 2 is in special cases, right, we're going to output plus is equal to special cases of si I plus 2. Okay, and then we're going to say I plus equal to 2. Else, we're going to say output plus equal to normal cases s of I, and I plus equal to 1. Return output. And this works. Okay, so now let me explain why this works. So what are we actually doing here? So what we're doing here is we are taking an element and we're checking if the element after it, so this is string slicing here. I'm going to take, an element and the element after it, assuming that there is an element after it. And we're going to check if it is in a special case. If it is in a special case, we're going to add the hash map value to the output and say I plus equal to 2 because we're skipping. We're going to be skipping 2 indexes since we checked 2 indexes, right? So how does this actually work? Let's look at the last case here. So last case is basically all subtractive cases. All right, so for example, CM is a subtractive case. So, here it's at M, it's going to check if MC is a subtractive case. Obviously not, so it's just going to plus M here. So that's going to be 1000. Now it's going to C. It's going to check if CM is a subtractive case. Yes, it's going to add the value of CM, which is 900. So you get 1900 already. And then we're going to skip to X. Let's say, is XC a subtractive case? Yes, again. So that's 90. And then we're going to skip 2 again. We go to I. Is IV a subtractive case? Yes, that's 4. So that's how we get 1994 or 1994. And then we return that. Okay, that is absolutely trash. Hopefully, okay, there we go. That's it. This is better. This is what I submitted like a while ago. So runtime is 99.37, memory would be 98. That's pretty good. And that's the same exact thing here, right? I don't know what changes. Unfortunately, Leetcode just, whenever, you submit, it varies. So you don't really know what the runtime could be. I mean, like, it's 26 now, but like 2 minutes ago I was at 59, and then I was at 42, so that's not really indicative of how well the solution. So now it's at 89, so that's decently good. Basically, the point is that you need to use a hash map to solve this problem, and when you use a hash map, it becomes a pretty easy problem. So this is a really good exercise if you're just starting to learn. It's good to learn hash maps like this. There's not really much manipulation of hash maps here. I mean, you're literally just manually putting in the hash map. If you really did want to learn more about hash maps or introduce yourself to hash maps, I'd recommend problem number 1, which is 2-sum. That is a real good hash map introduction. This one, yeah, I mean, you use hash maps, but it's more of this thing. Okay. A follow-up, a really good follow-up to this would be integer to Roman, which I'll cover in the next video. So my solution for this one reached 99%, and my solution for integer to Roman also reached 99% using the hash map. So as you can see, they're very efficient. So do not ever write like 14 different if statements. If you're on Leetcode and you're solving a problem and it becomes too complicated, you're probably doing it wrong. There's always a simpler approach that's going to be like, oh, wow, how did you think of that, right? So if your solution is getting a little bit suspiciously too complicated, then you should probably stop and rework. Okay. Thank you very much. and I'll see you in the next video.